Today's wonderful fall-themed video is solving two-step equations. Before we get started, here's some super important reminders for how to keep your work organized and solve your problems successfully. First, solve an equation in steps shown vertically, not horizontally. The second is keep each successive stage of the equation with equal signs lined up, each one below the previous one. The third is to simplify each side of the equation separately before adding or subtracting quantities on each side. So you want to simplify each side individually first. The next one is to show explicitly what operation you are doing to each side. And the last is to check your solution in the original equation. Please either write an abbreviated set of these reminders in your notebook or take a screenshot of this page so you remember to do this later. These steps are super important for both keeping your work organized, showing me what you're doing, and justifying your answer. Our first problem is 4x minus 3 equals 17. You may notice that this problem has both multiplication with your x, and it also has an addition or subtraction operation on the same side as your x. Previous equations that you've solved with this chapter would include things that look like 4x equals 17 or x minus 3 equals 17. This problem, however, incorporates both of these ideas into one. Remember in the reminders it told us to simplify each individual side first. Since this problem you can't simplify either side anymore, you can go ahead and move on to the next step. I went ahead and wrote step 1 here, and I hope that you'll also write that on your paper. The second step is to start working on getting x all by itself on one side. If you remember from previous lessons, whenever you get x by itself on one side, or whatever variable you have alone on one side, and you have that variable equal something, that's when you have your final answer. In isolating x, the first thing you do is add or subtract values from both sides. So we want to get rid of this plus 3, so that we have just the x term by itself. In order to do that, we have to add 3 to both sides. To restate what I said in the reminders previously, make sure you're very clear about what operation you're doing to both sides. So here we get 4x on the left side equals 17 plus 3, which is 20 on the right side. The next part of isolating x is to divide or multiply values on both sides. So here we want to get x by itself, so we're going to divide 4x by 4. So we also have to divide 20 by 4. These will cancel out on the left side, so you get x equals 20 divided by 4, which is 5. And your final answer is x equals 5. The last step is to check your answer. So take this last statement, your final answer here, and put it back into your equation for x. So then you get 4 multiplied by 5 minus 3 equals 17. So order of operations says you do 4 multiplied by 5 first. 4 times 5 is 20. Minus 3 equals 17. 20 minus 3 is 17, which equals 17. So those statements are true, so you can check that off and you know you got it correct. Notice that in this problem, I worked vertically rather than horizontally, and I kept my equals signs in a straight line to keep my work organized. I expect your work to look similar. Our next problem is negative 13y plus 5 equals 96. So if you look back at our notes, you know our first step is to simplify each side individually. In this problem, just like the last one, there's no simplification we can do to each individual side. The next thing we do is add or subtract any terms that you can to work on isolating x. Here, we can subtract 5 from both sides. Minus 5 and minus 5. So now we have negative 13y. These will cancel out, so plus 5 minus 5 equals 0, so they're gone, equals 96 minus 5, which is 91. Our next step is then to multiply or divide anything from either side to work on isolating x. So we'll divide the left side by negative 13 to get y by itself, and we'll divide the right side by negative 13. On the left side, you're left with just y. And on the right side, you get 91 divided by 13, which is 7. And since you have a positive number divided by a negative number, your answer will be negative. So So you box your answer, and now you go back and check it. So you do negative 13 multiplied by negative 7 plus 5 equals 96. 13 times 7 is equal to 91. So you have a negative and a negative. A negative multiplied by a negative equals a positive. So it's positive 91 plus 5 equals 96. 91 plus 5 equals 96, which is equal to 96. So your answer is correct. Again, notice that I'm working vertically in both the check and the original problem, and also that I'm keeping my equal signs pretty well lined up throughout, just to keep my work clear. When we're solving an expression, like this one here, we follow PEMDAS for our order of operations. Notice that when you're solving a problem, a two-step problem like this one here, they're actually doing reverse PEMDAS. So you do all of your addition and subtraction first, like this part here, where you're subtracting 5 from both sides, or if it was a minus 5 in the original equation, you'd be adding 5 to both sides. And then you do your multiplication and division next. So after you solve this part here, then you're going to divide both sides. So that's one way to help you remember it. So when you're solving an expression with no variables, like your check, you're using PEMDAS for order of operations. But when you're solving an equation with a variable and you're trying to do two-step or multiple-step equations, you use reverse PEMDAS. In your next equation, remember that the first step is to simplify each side individually if possible. So here you can do 2w minus 5w. 2w minus 5w is negative 3w. So negative 3w equals negative 63. You can divide both sides by negative 3, just like our one-step equations. So you get w equals 21. And since it's a negative divided by a negative, your answer is going to be positive. So w is equal to 21. Don't forget to do your check, which I went ahead and did over here for you to make sure your answer is correct. Here are some more challenging problems for you to try on your own. This is when you want to pause your video, try all of these problems on your own, and then I'll work through them and show you the answers. Now that you've tried these problems on your own, go ahead and check your answers with mine. If you feel confused, look through my work and see if you can figure out where you might have made a mistake. If you have questions, please circle the problem and make sure you ask me in class. Because question number 7 was really tricky, I left question number 8, which is a similar type of problem, so that I could do it with you in the video. Remember that the first step is to simplify each side individually. Since each side is already simplified, we can move on to adding and subtracting numbers to try to get the variable term alone. Unfortunately, we have these tricky absolute value symbols that we need to get rid of first. So remember, to get rid of absolute value symbols, you split the equation into 2. You'll have 2c minus 1, which is the same problem on the left, but without absolute value symbols, equals positive 35. And you split the other side into 2c minus 1 equals negative 35. Remember that the only way to get rid of absolute value symbols is to split the problem into 2, where you have the positive version of the answer on one side and the negative version of the answer in the other problem. Now we can go ahead and solve normally. We'll start with the problem on the left. So now we can add 1 to both sides to get rid of that minus 1. So plus 1 and plus 1. So we get 2c on the left equals negative 35 plus 1 would be negative 34. Now we divide both sides by 2 to get c alone. We get c equals negative, because one of the numbers is negative and one is positive, 17. On the other side, we do the same thing. We add 1 to each side, which gives us 2c equals 36. Now we divide both sides by 2. And you get c equals positive 18. So your answer is either c equals negative 17 or c equals positive 18. These are both solutions to the problem. And if you only have one of these solutions to the problem, then you have not fully completed the problem and it is not completely correct. To save space and time, I didn't do the written checks in these answers, but make sure you're checking them all by yourself on your own paper to make sure your answers are correct.